part 3 from the China-Italy Laboratory of Advanced Manufacturing, CI-LAM. And today we are focusing on the special topics towards zero breakdown from reactive to predictive maintenance. And first of all, I will show my warm welcome to all of you. And let me take several minutes to have a brief introduction to CI-LAM and Professors Sergio and also 4 startups who are invited to join this session. You all know that, yeah, I should change to another, yes. Now you all see that the CI-LAM is the name, the full name is the China-Italy Laboratory or Advanced Manufacturing. The mission of this joint lab is to promote and enhance the results of a joint cutting-edge research and development, including mutual technology transfer and valorization. And the vision is to be the most effective collaboration bridge between Italy and China in area of advanced manufacturing. And there are, you see, there are altogether 5 founding members. Yeah, the first one is the University of Bergamo, and the other is the University of Naples Federico II, and Tsinghua University, and 2 incubator and industrial organization. One is Campania New Steel, and the other is China Science-Tech Automation Alliance, which I come from. And also you can see the logos of these 5 universities and organizations. In fact, now we have got application from several other universities. For example, China South Science and Technology University, and also we got several applications from Italy side. So I can see that in the near future, the members of the joint lab will be increased to about 10. Yeah, this is my view. Yeah. And also you can see there are inclusive model. We have for the research area, and also we have some bodies come from the industrial alliance area. And the action plan of the CI-LAM is to do researches, of course, to do some joint researches, and to make some programs, yeah, training, education, and also exchange and mobility programs. And now we are making one of these such programs. And the CI-LAM will also support in standardization development and also provide strategic services to startups and SMEs. And also we will do demonstration and valorization of advanced technologies developed by joint laboratory. And in the future, yeah, interaction and cooperation, yeah, must be the main task of CI-LAM. You can see several pictures of the joint activities carried out in the passing 3 years. CI-LAM was first initiated at year 2017. And in the past 3 years, we have made several conventions, seminars, and kickoff start visit, and some exchange and visiting activities. Okay, in the upper left, you can see the opening ceremony of this CI-LAM in Bergamo. Yeah, in two years ago. Yeah. And now the CI-LAM Academy, we come to this year. Since the virus issue, we have moved all our activities to online. And now we are making the 2 series of seminars. The overall, the comprehensive name is The Power and the Future of TechX. And in our name, in the innovation webinars, now we are in the part 3 of innovation webinars. The name is Power of TechX. And the other name, The Future of TechX, will special design for the students of graduate and the PhD students of both from both countries. And the innovation webinars from professionals, managers, and researchers aimed at promoting an effective innovation ecosystem exchange between China and Italy on advanced manufacturing. And now today we have a short program. And first of all, after my short introduction, we will welcome a keynote speech come from Professor Sergio Calividi, and he's come from University of Belgrano. And followed by the keynote speech, we have 4 startups, 2 from China, 2 from Italy side, and they will give their own solutions and their own best practices in this area, in this topic. And finally, if I have time, I prefer to have 10 minutes of a Q&A. Yeah, so this is the basic information of today's seminar. Okay, and now we all welcome Professor Sergio to give the keynote speech. His topic could be towards zero breakdown from reactive to predictive maintenance. Okay, Professor Sergio, now it's your turn to share your own screen.
Okay, thank you, Jason. Thank you very much for the introduction. And as Jason was stating, I mean, this is a series of webinars we are organizing above all for talking about the practice. So my speech will be, okay, talking about also the research side, but above all some, let me say, suggestions for practitioners. Because on the other hand, we have other kinds of seminars in the summer school format more devoted to the researchers. So I will try. I mean, what I did in preparing my presentation has been having a more, let me say, understanding of the current issues that we have in what is really intriguing, the possibility to conduct, to manage machines in a zero breakdown mode. But let me say, this is utopistic at the moment vision. This is, of course, the asymptotic level. Try to have all the machines without having any real failures. But I mean, the journey, the trajectory towards having this kind of, let me say, utopistic condition, it's quite long. And so my talk will be more on understanding which are the main issues in trying to conduct a real, what is called predictive maintenance. So first of all, what I will talk at the moment, at the beginning, is try to make some definitions. Most of you are aware about what is maintenance, which are the different policies we have at the maintenance level. Let's talk. I'm talking about the evolution of the maintenance policies, but I don't want me misunderstood about this term, because really, when we talk about from reactive to predictive, it's not only talking about reactive as an evil. I mean, the reactive maintenance as something we have to abandon at all, and predictive as the target that we have to reach. But we can have the compressions, we can encompass all different kinds of maintenance policies within the same plant, within the same factory. So when we talk about reactive, we talk about having, I mean, the main example is the lamps, the light bulbs. We fix the light bulbs when they are exhausted. So when we switch on the light and that doesn't work, then we change the bulb. So that's the idea of reactive. I fix the problem. I fix the fault part when the broken part, when it's real, that doesn't work, or there is a strong degeneration of the functioning of that part. So reactive is, let me say, as the term says, is acting after the failure has occurred, has happened. Then we have the planet. So when we change the oil, when we go to the garage, to the workshop with our car, and which we have the oil or the filter changed, I mean, this is a kind of scheduled maintenance activities. It's planned every year or every 2 years. I mean, every periodic time, which is normally, for example, fixed by the machine provider. In our case, the car provider, the car constructor has some suggestions for maintenance of the machine, of the car. And so we go to the garage every year, every 2 years for having some parts of our car being changed. So this is the scheduled maintenance activities, considering some specific, let me say, KPIs, indicators. That could be the mileage of the car, or can be a time, no? A time when we have, for example, the revision of our heating system in our flat, in our house. We have on a yearly basis, also for certification for safety purposes. Then we have the proactive. Proactive, and when we start going towards the proactive, the engineering side starts being more evident. When we talk about proactive, we talk about try not only to fix the problem, but to diagnose the reason why the problem has been occurred, and try to understand on how to eliminate the defect, the problem as a whole, in order to avoid the reoccurrence of the problem again. And then there is this magic word, which is predictive. That means having a kind of crystal ball and try to elicit from data, from some information, the residual life of a component in order to declare the, let me say, the euthanasia, the change, the moment when I change the component just 1 minute before the problem or the breakdown could occur. So in the predictive idea, I mean, the main intention is try to exploit the whole life of the component, of the part, and act in changing the part just a minute, let me say, a second before the part would break down. So I'm talking about a magic word, because normally also in the standards, in definition, predictive normally it's associated with condition-based monitoring. So we must be very careful in understanding that in most of the solutions that are available on this specific area, they are more condition-based monitoring rather than predictive. The distinction between condition-based monitoring and predictive is that condition-based monitoring is like, let me say, the alarm of the fuel we have in the car, no? And we have the light which is put into evidence the fact that we have in a reserve mode, in a reserve condition with the fuel in our car. And so this is condition-based monitoring. This is one signal, the level, the number of liters, for example, of the fuel, the petrol in our car, in our tank, and this triggers a signal. The signal is the condition-based monitoring. The predictive is different. It's okay, now you have a certain amount of liters, but I can presume from your previous behavior that you still have 50 miles available till the tank will be empty. So this is the definition, the distinction between conditions-based monitoring and predictive. And as I told you, most of the solutions which are available are more conditions-based monitoring, based on some signals which trigger some conditions about the possible malfunctioning of the asset, while predictive is much more difficult to implement. I mean, try to have an understanding of the possible residual life. So some suggestions from my side. So predictive maintenance, it's a very fashionable, is very intriguing. I mean, trying to understand the residual life, but as I'm writing here, not all that glitters is gold. So we must be very aware and very careful when we apply in the companies, in the daily life, predictive maintenance, because there is, I mean, there are some pros and cons. Okay, so we must having an engineering attitude in trying to understand if and when and how predictive maintenance can be applied. So first of all, there is no off-the-shelf solution we can buy. I mean, we cannot have the idea of buying a software. Let's take a software from the shelf. We implement predictive using this software. I mean, each solution, each condition, each factory, each machine has a different, it's like a human being, has a different way to react to some conditions. So predictive maintenance is not a software, it's a project. So it's different, it's a study. So it's much more difficult to implement than just implementing a software like an office solution in our laptop. The second, pick the right assets. What does it mean? I mean, as I told you before, we have to escape from the imagination that reactive maintenance is bad and predictive is good. I mean, we can have, like the example of the light bulbs, we don't use, it's useless to use predictive maintenance in predicting the residual life of the light bulbs in our house. I mean, when they break down, when they don't work anymore, we change them. So in this case, reactive maintenance is the right solution for fixing the problem. It's useless to have a predictive approach. While if we are in a nuclear power plant, of course, when we have a specific kind of components which are very critical from the safety, from the environmental point of view, I mean, it's important to try to control them and avoiding any breakdown, because this could create a very bad escalation in terms of impact from the safety, environmental, and so on. So pick the right assets means, in order to understand if predictive can be applied, we have to understand where it's more function to be applied. The overwhelming goal is to maintain optimally, not to over maintenance. So the other thing is that we have to try to have let me say, an over maintenance, over service of our machines. Maintenance, it's a cost. It's an investment, of course, but it's also a cost. So when we want to maintain, we have to understand that it's not just, we have not to take into account the technical part, but also the economical part of maintaining. Maintaining means having sensors, having engineers, having operators, so it's a cost. So we have to avoid, that's the risk, not with the predictive. I mean, companies which didn't maintain or didn't have a good maintenance of their assets, then they shift rapidly to an over maintenance. So it's very important to understand where and how to maintain in order to take into account the impact on the total cost of the maintenance. When we talk about total cost, we talk about not only the, let me say, operational cost, but we talk about the total life cycle cost of an asset. So maintenance is not just operations, it's not just execution on the asset, but it's an engineer. We have to adopt an engineering perspective. So when we design a new machine, when we engineer a new machine, when we from the provider's point of view, or when we purchase a new machine from the user point of view, we have to take into account not only the cost, the investment in buying and in selling the machine, the transactional cost, but we have to take into account also the lifelong costs that we need to take in. are committed throughout the life cycle of the machine. So it's very important to understand that an equipment, it's as a multi-year exercise, multi-year perspective. So we have to understand, maybe we can buy a machine which is much more expensive, but with reduced maintenance costs, or vice versa. Maybe we buy something which is much cheaper, but we know that then we have to maintain better. We have to have a better maintenance of the machine. But this should be made at more system point of view and a life cycle point of view. Finally, another, let me say, suggestion from my side. Let's remember that predictive, this is related to my first statement. It's not the software, but requires also brainware. So in a company, we need to have competence. We need to have people that understand what is really predictive. In most of the companies we work with, normally the maintenance personnel is represented by technicians, by people who have very, very good understanding of the technical facts of a machine, but they don't have an engineering perspective. So we need to have engineers. So what we are doing in our university, for example, is to train, to educate our mechanical engineer students in order to have this competence on maintenance, on engineering a maintenance system. And most of the companies, this is still lacking, having a kind of, let me say, white collars, have a kind of maintenance lab within the company, which performs a maintenance engineering activity. So this is what we stand when we talk about engineering and maintenance system. So in order to optimize an industrial asset management, we have to take into account the whole plant life cycle, which of course should take into account the design phase. That means use of life cycle cost approach, reliability center maintenance, failure mode effective critical analysis, in order to understand which are the main, let me say, components which are more the most critical ones where to adopt more tight maintenance policies. But we have also to consider that we have to have also this orientation towards people. So adopting a lean approach, total productive maintenance. So try to make the operators who work on the machine be the first maintenance people, providing first level maintenance activities, having this continuous improvement. So maintenance is not just fixing a problem, but trying to have every day a continuous improvement. And of course, a strong attention towards safety and prevention. So, I mean, as I'm telling you, predictive is not just an algorithm. It's not just applying a software, but it's part of a more complex engineering way of conducting a maintenance system. So the main idea is that when we manage individual assets, when we approach some maintenance policies, we have to take into account that this is part of a more complex environment context, where we have to take into account the role of individual assets within the systems, the management asset portfolio, and the impact on the corporate organization. So as I told you, this is also requires also an organizational perspective in a company, in trying to understand where to allocate the roles and the decisions between different people operating in a company. I'm using this slide from the Sino-German Industrial Working Group, just to make you aware of the fact that also the application of maintenance software, it's one tile of a puzzle, let me say. I mean, just in a few words, because this is much more complicated to explain. But if you consider different decision-making levels at the ISO, at the ISA 95 perspective, I mean, we have the physical layer and the sensing layer till to the ERP layer. We have to understand that we have different moments where we can apply maintenance software, because we need to have the sensing activity, the condition monitoring, the fault diagnosis, the prognosis, the scheduling. So, I mean, it's not, as I told you, just one software to plug in, but requires an understanding of the whole architecture, also from the IT level, and in order to understand how to perform a good maintenance activity. This is consider also how complex is to implement prognostics or predictive maintenance. We need to have good data. So one important thing is to have very good data. Be careful, big data is not good data. Maybe we have a lot of data in our data warehouse, but then we need to understand which data are useful for. So most of the problem is that we think that we have a lot of data, so we can provide, we can have a predictive approach. But at the end of the day, then we understand that most of this data are dirty, are not good for our purpose. So data acquisition, data cleaning, data manipulation, it's very important and time consuming, because before having good data, we need to have a lot of time of registration, of possible breakdowns, and so on. Then we have the state detection, the health assessment, the prognostic assessment. I mean, each of these boxes requires specific software, specific algorithms, specific competence also. From the automation part, we need also to have people who are very skilled in mathematics, from statistics, and so on. So it's quite complicated. And of course, we have software which can provide a support for each of these boxes. But then we need to have a brainware. We need to have people who are able to master this kind of software. Just before leaving my speech, because I mean quitting, because then I think, Jason, we need to give the floor also to the startups to understand how to really, these opportunities can be implemented. I give you two different examples of two projects we performed in our lab on, for example, how to use the electrical signature analysis for having a low cost, let me say, condition-based monitoring. I mean, this is not predictive. This is conditions-based monitoring. The main idea is that we can use the electrical signature pattern of the current, the line current and voltage of an electrical machine, of the power, let me say, of a machine, in order to extract information about the health of the electrical engine, the electrical machine. So it's like we talk about electrical signature because in normal condition, maybe I mean, this is an example we in our lab we made. We can have a specific pattern. It's like our signature. Okay, so this is a signature in the normal condition. This is the absorption of the electrical intensity, and this is we say an evidence of the normal functioning of that specific device. While, for example, we conducted some experiments. For example, we created an obstruction in the pipe, and this resulted in a different electrical signature pattern in comparison with the normal condition. So, I mean, using the electrical signature is a proxy for a low cost, because we don't have to put some sensors which are very costly. It's a very low cost approach in order to have already an idea, an orientation about the possible malfunctioning, and also understand which are the parts of the machine which are not functioning properly. Another example, the second one, is we performed in a company using brake systems. This is predicting degradation of a blowing machine for sand cores. So understanding before the occurrence of a problem, of a quality problem in the creation of the sand cores, understanding the possible malfunctioning. In this case, what we analyzed, what we did with the company was sensorizing the machine with some specific sensors on pressure, temperature, humidity, and so on. Then we performed two different kind of, from the comparison between a regression model and application of artificial neural networks. So artificial neural networks are a black box approach in order to deduct, to have an understanding representation of a specific pattern or estimation of possible malfunctioning. So in this case, we made this example between the regression model and the artificial neural networks. Artificial neural networks, since they are black box, they don't require an analytical form, so are more usable when we don't have the possibility to create a real analytical understanding and form of the relation between the input and output variables. Finally, this is a slide I got from colleagues from Politecnico Milano. We have a collaboration between our groups on what we call maintenance digital twin. We know that, and Jason was also talking about the digital twin. And we had the first webinar about digital twin in smart grid. So also in the maintenance, we can talk about the digital twin. That means having the counterpart, the digital counterpart of the physical components. In this case, in order to have this kind of maintenance avatar, let me say, we need to, as I told you, have the right components, software components for each of the phases. So once again, we have data acquisition, data manipulation, state detection, health assessment, prognostics, and finally, what we call advisory generation. So the main idea is that the operator has a kind of dashboard, like the dashboard we have in our car, and they can have an understanding of the possible malfunctioning, alarms, and the residual useful life of a component. So that's all from my side. I just quote this, I used to quote this statement, this sentence from Eric Hoffer, because I think that now, more than before, since we are carrying out, I mean, my experience is that 10 years ago, when we have the Lehman Brothers crack, companies started reducing investment in the maintenance, because maintenance is considered normally a cost. So they started reducing heavily the investment in the machine, in maintenance and machine, but this created a fast obsolescence of the machines. And so my recommendation is that since we are in a very critical economic period, don't make the same mistake. So try to keep maintaining, because then at the end of the game, let me say, if you don't keep maintaining, if you don't have this continuous maintenance, then your cost will be even higher years after. So maintenance is, let me say, something that normally is not considered a noble action, because maybe I mean, it's considered more a cost than investment, but more than the past now, you should consider it as a real investment that companies should invest on, not only for the machine point of view, but also keeping training people, keeping the right level of competence at the engineering level. Okay, thank you, Jason. I think I finished my speech, and of course, maybe during the discussion we can go on eventually with Q&A.
Okay, thank you, Professor Seguin, for your fantastic presentation just now. And we all see that Professor Seguin gave a general picture of the predictive maintenance and some key points. Okay, and also several case studies. And we will lead to the other steps, and finally at the Q&A stage, we can give some time to audience to have the interaction with Professor Seguin. So thank you, Seguin, once more. Now we come to our next stage. We have together 4 different startup companies from China and Italy side. And the first one, I would like to introduce my alumni from Tsinghua University, Mr. Liu Jian, China name. His English name is Jeff, Jeff Liu. And his company named Inshi. Yeah, Inshi is a very innovative company in this area. And also we have some in-depth collaboration on the digitalization and transformation of China industry. Now welcome Jeff Liu to give his speech. And we will ask Italy company startup to give a preparation. Okay, please, Liu.
Okay, let me share my screen.
Yes.
Is it okay, Jason?
No, no.
Can you see the screen?
No. You can try to share your screen.
Okay.
Your full desktop, not only the. Yes,
Now you,
good.
now you can see, right?
Yeah, I can see from the very beginning. Yes, good. Start.
Okay, good.
Please.
Okay.
Yeah.
First of all, thank you, Professor Cavalieri, for your very valuable knowledge sharing. And good afternoon, good morning, Italian friends, and good afternoon, Chinese friends. I'm Liu Jian from Inshi Technology. It's my pleasure here to share with you the topic, predictive maintenance, how to be effective and efficient. Okay, let's start. According to McKinsey, the predictive maintenance will contribute a lot to enterprises in reducing maintenance cost, reducing downtime, and reducing the capital investment. And from the experience of our customers, we also found that the benefit from predictive maintenance, including also increasing the production safety, decreasing the HR cost, increasing operation efficiency, and quality management. So to my knowledge, the predictive maintenance is to apply advanced technology plus this industrial knowledge to optimize the asset management. And the technology applied include the prognostic technology and the prediction technology. And the prognostic technology is majorly to prevent machine fault and reduce the machine downtime, while the prediction technology is to improve asset management and reduce overall operation costs. So what's behind these technologies? It is what we call the predictive analysis. According to PTC, predictive analysis is use of data and the statistical algorithm and the machine learning techniques to identify the likelihood of future based on the historical data. In another term, the predictive analysis is based on data to analyze history and predict future. By applying technology like statistical analysis, model-based analysis, data mining, and machine learning. Now let's move on to the case study. This case study is from our customer, one of our customer. It's about a steam turbine machine. The machine broke down and without any sensors issues alarm signals. So the customer expect us to answer the following questions. First, any omen before machine fault, and how to identify the omens. And what's the actual happened during the omen period, and what's the condition trend of this machine. So the customer sent us a data set which contains data 6 weeks before the machine fault. This data includes 56,000 data, each has 15 sensor values. So like the time series shown in the screen, here is the 15 sensor time series. And we can find that is with traditional method, it's very difficult to answer the question the customer asks. So we applied our predictive analysis techniques. First, we do the health assessment based on this set of data. And this health assessment, actually we combined the data fusion, pattern recognition, machine learning, and correlative analysis. We combine this together, we make this health assessment. And the result shows to the customer that about 2 weeks before the machine fault, there is a significant condition change. It already has this kind of condition change, which means 2 weeks before the machine fault, there is some omens, very obvious omens, even though none of the sensors issues alarm signals. The second step, based on the abnormal time segments we identified in the health assessment, we did the abnormal analysis for this abnormal time segment. And we show the customer during the abnormal time segments, there are several sensors whose value have had this significant change. And the customer were quite surprised. They said, okay, this sensor value change means that the spindle became less crowded. That is the very obvious omen of the machine fault. So this is what we did, is abnormal analysis. And finally, final step is we help the customer to do the condition stability trend evaluation based on the data set. And we come out this stability trend picture. And we show the customer before the machine fault, there are 4 time segments in which the condition of machine actually had a very significant change. So the customer said, well, this is very impressive. If we had such information, actually we can start the inspection and maintenance before the fault. And we could be able to just avoid the machine fault. So in summary of this case study, based on 56,000 times 15 machine sensor data, we create the condition model for the machine. And we did the health assessment, abnormal analysis, and the stability evaluation for the machine. And we, together with our customer, we spend less than 5 minutes for the whole process. So the conclusion is, by applying the advanced predictive analysis technology to predictive maintenance, the customers benefit from effective and quantitative patterning of machine conditions, which means they can monitor the machine condition in a more accurate and easier way. And also we can realize the efficient implementation of predictive maintenance. I fully agree with the views from Professor Cavalier that the predictive maintenance actually is an engineering system. It's not just an IT system or data system, it's an engineering system. Okay, so when we implement this, when we help the customer to implement a predictive maintenance system, we offer our predictive analysis technology and combines customers' experience and industrial knowledge, so we can realize the quickly and the more effective implementation of the predictive maintenance system. So this all my presentation. Thank you all.
Okay, thank you,
Yes,
Jeff Liu.
thank you.
Yes, thank you, Jeff Liu, for your great presentation. Shortly but very effective. And since I have together here several times of your presentation, each time I have got some new insight from you. So thank you so much once more.
Thank you.
Okay, please give your screen back to me. Please quit your share.
Okay, I will stop my.
Yeah, stop your sharing.
Go back.
Yeah, no. You just you have to stop your sharing.
All right.
Okay. Yes.
Okay.
Yes. Thank you. Yeah. Thank you. And next one. Yeah, we all are waiting for our next presentation from Italy side, a new startup. The company name is Axoware. Axoware Industrial Asset Management Company. And this company is a new spin-off company from the University of Bergamo. And there are 3 founders. And we are now invited the second one, Emmanuel Doel. Maybe I'm not correct, I'm not sure, to give their speech on the new start and their presentation, their use cases in this asset management area. Okay, so
okay.
Please give your presentation, and I will.
Thank you, Professor.
Yeah, I will quit my presentation.
Okay.
Okay, please.
Here. Okay. Okay. Thank you, Professor. So, good morning, everyone. I'm Emanuele Dovere from Exolvia. Exolvia is a spin-off of the University of Bergamo. In particular, our experience in University of Bergamo is related to the Department of Management, Information and Industrial Production Engineering. The spin-off was founded in 2018, but our experience has been grown through research and industrial projects carried out from 2008. Our competencies are related in maintenance engineering and industrial asset management. And the experiences done in several projects has been the foundation to create our company. In this slide, you can see our mission and our vision. Our mission is to create value for companies through design, engineering, and development of solutions to manage industrial assets, with a particular focus on maintenance processes. Our vision is to enhance the scientific and academic know-how that we have. Here you can find the founding members. One is me, Emanuele, the other is Enrico Cagnoni, and Roberto Pinto, who is associate professor of the University of Bergamo. So, before telling you our company's solutions, I would introduce you the old approach of maintenance management. As example, we can consider a production line. The production line is not managed like a whole entity, but each machine is considered separately. There are no historical data of maintenance interventions, no signals collected by sensor, and no connection among the single machines. Only when a failure occurs, the maintenance technicians operate like firefighters in a reactive way. And the only preventive maintenance is related to inspections needed by legal constraints. Moreover, all the information about materials, spare parts, instructions manual, technical draws, the skill of the technicians, and the availability of budget are not integrated. And each time you need this information, this document, this data, you have to find them and increase the downtime of the machine. So it's time to jump in a new era of maintenance management. As Exolvia, we provide two different kinds of solutions. The first one is a software. We have two releases of this software. One is called EasyCMMS and the other Easy Service. This software allows to manage the whole maintenance processes. The software is delivered in software as a service modality, is all in cloud, and is active on Heroku, that is a platform developed by Salesforce. With our software, all the data from the sensor are collected, and you can manage all the documents and all the data in cloud. The documents, the data, the information that you need are available on cloud, and you can achieve them by mobile instruments or PC, but the important thing is by mobile instruments like a smartphone or tablet. The second activity that we provide for our customer is to develop maintenance policies with a particular focus on condition-based maintenance and predictive maintenance, using data collected from the machine and indicators collected by EasyCMMS. In cloud, we can develop the artificial intelligence to manage all this data and to make a sort of digital twin of our assets. As example, I show you one of our projects in a company that manages the integrated water system. In this case, we realized a system for the smart metering and leak detection. We used a smart meter in different nodes of the network, and we analyze different signals like flow rate, pressure, and so on, to evaluate the consumption and the possible leak. Here you can see the model of the network and the related nodes, and we compare the real data with the simulated data. To collect the data from the network, we use the smart meter and the LoRa protocol that allows the transmission of data with a low power. In these years, we have done different projects with several companies in different sectors, like automotive, food, metals, chemical, and public services. We born 3 years ago, and we are growing our collaborations and our expertise year by year. So if you need more information, here you can find our contacts. Thank you.
Okay, thank you, Dor, for your short but also very effective introduction.
Thank you.
I hope that you can get some insight from your presentation and have a discussion with your China colleagues. Okay.
Thank you.
Okay, thank you. Now let's come to China side, and we welcome Dr. Jin Wenjing, okay, from Cyber Insight Technology Corporation, which is a new startup in Beijing, and to give her introduction about herself and the company's business. And now welcome Jin Wenjing, okay?
Hello.
Okay, please share your own screen. Yes.
Sure.
Good.
Okay, good afternoon, everyone. My name is Wenjing Jin. Thanks to the CI-LAM, and thank you for inviting me. Today I'm going to share a presentation on the industrial AI for smart manufacturing applications on the PHM topic. First, I want to introduce myself. I received my doctoral degree from IUCRC, Center for Intelligent Maintenance System from University of Cincinnati. My advisor is Professor Jelly, and he is the global academic leader in industrial AI and predictive maintenance. After graduation, I came back to China, start the startup company Cyber Insight. I am the chief data scientist. I received the honor of SME 30 under 30 for recognizing the future leader of manufacturing. Cyber Insight is a spin-off company from IMS Center. We aim at landing the industrial AI applications to achieve the worry-free industries. We started a team of talents with multidisciplinary capabilities on the domain knowledge, AI modeling, and edge computing. And half of our co-founders are doctors from IMS Center. We set a goal for ourselves. We will land 100 worry-free lighthouse cases in 10 years, definitely with the helps from the partners. About the IMS Center was established in 2001. It has conducted more than 100 industrial projects with over 90 members worldwide. The research applications include the machining and the predictive maintenance for the transportation, semiconductor, and so on. The IMS Center has generated more than 800 million. Yes? Pardon me?
No, we can hear you. You can go on.
Okay. Sure. So below shows the projects our co-founders used to work with, like the GE, Alstom, and Applied Materials, etc. So the key of the new maintenance strategy is to solve and avoid the hidden problems in the invisible space. It's like the iceberg. You would say like the machine failures or product defect, and they are like the top of the iceberg, but the degradation has been accumulated, like the wear, cracking, or fatigue. But it is barely noticed until the failure is formulated. That's why we want to monitor degradation. We monitor the signals and convert the signals to useful information so we can predict the degradation trend and estimate the remaining useful life. So the mission is to enable the product or system to reach the near zero breakdown performance. We call it zero downtime, zero defect, and zero waste. The PHM techniques plays a key role in the industrial AI. It requires 4 types of techniques that includes the analytics technology, data technology, platform technology, and operation technology. And in the following slides, I will share a couple case studies in the PHM applications. First one is from the transportation. As far as we know, predictive maintenance is the future of the railway maintenance strategy. The Alstom is leading at the train health management and prognostics. Since 2015, I have been working with Alstom team to develop the research in locomotive motors, the rail track, and the point machine. And for example, we conducted the lab test and the field test on the point machines, acquire signals from the point machine motors, like the motor current or the speed and power, extract the signals and extract the features from the raw signal. And later we developed the fault diagnosis model. We can detect 30 types of different failure modes with different degradation levels. And the other case is from the wind turbine. As you know, in the wind farm, the key issue for the wind farm is how to improve the power generation efficiency and reduce the maintenance cost. So this platform provides a full stack solution for the smart service for the wind turbine, wind farm, and enterprise levels. It includes the 3 key subsystems: the CMS system, and blade predict, and maintenance scheduling. The entire system is broken down to 4 parts, from the data acquisition, edge computing, and onboard PHM, and the cloud center. So the multiple sensors like the accelerometers, thermocouple, or current sensors are installed in a critical component like the generator or the shaft on the drivetrain. It's like it's the function of the CMS system. So it can detect the condition of the drivetrain and can detect the early faults before the machine fail. And the other one is a blade predict. It's a smart add-on device. It can detect the blade early faults like the icing, corrosion, or the fatigue. So using this platform, it can help the wind farm to eliminate 15% of unexpected downtime and reduce the maintenance cost. The last case is from the steel manufacturing. As you know, steel manufacturing is the most energy consuming and costly industry. And the unexpected machine breakdown can cause huge damage and impact on the productivities and a huge loss as well. Also, thousands of assets are spreading at different locations across the factory. That's why it will require a lot of labor work to maintain all of these assets. So that's why we start an internet-based IoT platform for the steel manufacturing factory. So the manager and the maintenance personnel can easily access to the system, and the health assessment and the diagnosis model was developed for each machine, like each critical component and each critical asset. So they will know the condition of each machine, and based on this information, they can schedule the maintenance just in time. So as a result, it can increase the OEE by 1% and reduce the parts inventory. That's the end of my presentation. Besides all of these case studies, we also have many other success applications in manufacturing and chemistry, etc. And we can discuss later. And thank you for listening.
Okay, thank you so much, Wenjing, for your clear presentation. I hope you can wait a while so that we can have a panel discussion later on at the final stage. Okay?
Sure.
Please stop your sharing.
Okay.
Yeah. Thank you. Yeah. Now come to our final representative from a company, also a new startup company. Mint, right? And this name is very difficult for me, but now I see the name is come from 3 different words. So let's wait for their explanation where the name come from and what is your business, okay?
Of course, thank you. Thank you so much.
Welcome. Yeah, please.
Thank you. Let me show the screen. Let me share the screen. Okay. Share. Let me hear if you are viewing my. Can you see my sharing?
Yes, please change to play mode, right? Yes.
Okay. Hi everybody, my name is Roberto Nappi. I am an electronic engineer and I am also the CEO of and founder of CI-LAM. CI-LAM is Systems Engineering for Maintenance. So as you can hear now, the right pronunciation of our company name is CI-LAM. Okay, so I will show you the predictive and integrated maintenance management for Industry 4.0, and as you can see here, we are involved in several kinds of intervention areas like transportation and logistics, Industry 4.0, energy, smart buildings and infrastructures, and also in biomedical and healthcare. We are inside the startup incubator Campania Still in the science centers of Naples. So we have several kind of customers in railway environments like Italian Railway Company, RFI, Contact, and the Monticelli Group. And also we have several kind of several customers in industrial sector like automotive sector, FCA, and the other customer in the industrial sector like Surf Power and Wind Aeronautics. So as an innovative, we are an innovative startup. So we are several kinds of research partnership with the University of Naples, with the Institute of Microelectronics and Microsystems of the Italian Research Institute. We are also collaborating with University of Calabria and University of Salerno. And we have an industrial partnership with ST Microelectronics. So now we are involved in several R&D projects, national project and also international project, as you can see here on the right side of the slide. And our team is composed by several kinds of engineering. So as you can see here, we have electronic and electric engineer, software engineer, mechanical engineer, and automation engineer, because maintenance, our services related to the maintenance engineering is composed by several kind of knowledge. So in this case, we have covered the most important functionalities related to maintenance work. So on the right side, you can see our several kind of prizes that we have obtained in the last year in several kind of competitions. So let me show you our functional architecture of our system that we have developed to predictive maintenance for Industry 4.0. So we have a multi-layer approach using only one systems made by CI-LAM, and we have the layer one is the sensor layer about IoT solutions, and also powered by our techniques of energy harvesting. So when we have captured the signals from the fields, from the several kinds of fields that we are working with the edge-triggered computing, we can process these kind of signals, and after with the machine learning approach at layer 3, we can determine and estimate the remaining useful life about the device under test that we are monitoring. And after this value, this estimated value, this remaining useful life is sent to our software layer. We have developed an ERP to manage all the process related to maintenance activities, like to dynamic maintenance scheduling, about employee management, about supply chain management using blockchain, repair management processes, and using also augmented reality functionalities used by maintenance operator on the field to obtain the expected result during maintenance activities. So the CI-LAM platform is for several kinds of industrial sectors. So we have named or we have contracted the name of CI-LAM platform in CIPLA. So we have a diagnostic system about predictive approach on rolling stocks, and also for railway infrastructure. We have a medical and healthcare application about solutions to prevent epidemic and pandemic conditions. So we have in the field of the smart building developed a structural health monitoring system to predict fault condition in the build and also in infrastructures. And so we are also involved in several kinds of projects about industrial sector, and also in the energy systems, in the production in production systems of renewable source of energy communities. So thank you so much for your attention.
Okay, Napi, Roberto, thank you for your presentation. Now we come to the final session of today's presentation, and we come to Q&A. And welcome everybody. If you have any questions to the guest, Professor Sergio, and also for startups, please raise your problem. And also you can unmute yourself if you like. We have totally 10 minutes or so for this session. And for your convenience, I show this screen so that you can see the name and their company name. Is there any questions? Professor Sergio Gavaladi, I would like to see your, could you give some general comments to the 4 startup companies?
Yeah, thank you very much, because I think we we had understanding of 4 relevant examples of how it's possible then to start deploying more advanced techniques in maintenance. And I think that what came out also from the speech was that as Dr. Liu Jian was remarking again, the importance of having an engineering perspective. So Emanuele Dovere talked about the importance of asset management. So I think it's let me say, for me, it's a melody for my ears, because I mean, we have to have this kind of more asset management perspective. And I appreciate a lot also the speech from Dr. Jin Wenxing, and I know very well, I mean, the context where she has been working, because Professor Zhe Li is one of the most eminent, the most relevant experts in this area. He's a friend of ours as well. He's been in Bergamo more times, so it's we have a collaboration with the University of Cincinnati. So I think I mean, I was also aware about the kind of applications, but even I think Cyber Insight has a lot of I think there could be a lot of opportunities also for collaboration between our Italian startups and the Chinese. So I would encourage also the Italian CEOs, Mr. Dovere and Mr. Nappi, to follow up, to go on in maybe having another session with Dr. Liu Jian and the other, and Dr. Jin Wenxing, for understanding possible cooperation, because I think that there is what I found out was kind of a similarity, but a lot of complementarity in terms of application. Remember that what is important, for example, Mr. Nappi was putting into evidence the application in the railway, no? In the railway industry, and also Dr. Jing Wenxing was pointing out this. But we have to remember that, as I told you at the beginning, there is no plug-in solution, off-the-shelf solution. So the more are the, let me say, applications, vertical applications, the more is the wider is the portfolio that you can use towards your customer. So I think also enabling collaboration, then it's up to you, commercial agreement, in trying to put together the different perspectives, the different experiences. I think it could foster more, or could empower more your solutions. So my suggestion is having, as I told you, a follow-up. I think that the main idea and the main intention of CI-LAM is trying to have a kind of matchmaking. So I think this formula, Jason, is working quite well, because of course we had to select 4 startups. Maybe there are other representatives from startups or companies who are listening to us. So my invitation is not only to the 4 startups that had the floor, but also to other, to have another moment where to talk maybe more in depth about your applications and find opportunities for collaboration. And this is, I would say, also a measure, a metric of the success and result, the role of CI-LAM. So if you wish, we can organize another session, let me say more in a private way, more closed session involving those startups, which are really eager to collaborate between China and Italy.
Yes, I think Professor Seguin, your points is very impressive and important to all of us. I think in the follow-up stage, maybe we can organize a small group for close collaboration between these startups, even some other startups who are interested in this area. And please, let's the 4 startups. Do you have any comments or ideas about your own presentation or others? Could you give some points, please?
We have very appreciated the sentences of Professor Cavalieri, so we are available to interact with other startups, and we can have another session about our application.
Good.
Thank you.
Yes. Yeah. Wenjing, yeah, as a
yes.
lady, share your points.
Thank you, Dr. Wang, and thank you, Professor. And I'm so happy to have this platform to allow China and Italy startups to have some joint collaboration. I will follow up when you set up the further discussions. Yeah.
Yeah. Yes. We hope that at least in our following events, there are more beautiful ladies like you to join our session.
Thank you.
Yes. So you're a great example of this. Okay. How about Jeff Liu? Could you share your points or your idea? Any idea?
May I have a question to Professor Cavalieri?
Sure. Yeah.
Yeah. Professor, how is the development of predictive maintenance in the energy industries in Italy?
Yeah, I mean, as far as I know, there are very good applications in Italy because we have a very important utilities, which is called Enel, and they are carrying out interesting applications. So in the energy area, I think we can learn a lot from what they are doing. more, I mean, I would say it is the most relevant utility, because, for example, if we talk about, there are also applications in the water area, water system in treatment, but still lagging behind the electricity, I would say the electrical utilities. So as far as I know, there are some good projects. So eventually we can try. We have a collaboration with one company which is based in. I mean, it's the most important utility in northern Italy, which is A2A, and they are providing all the let me say distribution to the Lombardy area. So it's quite so. I mean, if you wish to have, I mean, we can have some talk eventually to have a better understanding on what they are doing.
Okay.
Are you interested in that?
Thank you. Yeah.
I was asking, are you interested in a possible talk or collaboration with?
Yeah, sure. Well,
Okay.
I really expect to.
Okay.
Because currently most of our customers is in the energy industry.
Okay.
So we're interested to cooperate with Italian companies in this area. Thank you.
Okay.
Thank you. I think it's also a possible way for the CI-LAM to build up such a bridge between our technical driven startups and the customers in Delhi locally. And also we can support as a remote one, because all the data business model could be online. And also we can offer some technical solution to your side. That I think the Delhi startup or partners could explore their business. I see all the two startups from your side doing a comprehensive business portfolio. They have a relatively complete solution, and our companies are more in depth. So that I think I see there are some combinations in the future, the potential in the future. So we can see the potential in this area at least.
Okay, thanks, Jason.
Yeah. How about the final one, please?
Yeah, so also for me, I appreciate a lot all of this presentation, and on my opinion, it's a great opportunity to have this kind of presentation, and no other colleague with maybe to have some collaboration. So I I hope that we will see, or we can have another situation like this. And we can talk about possible collaboration, because we work in different level of analysis. So on my opinion, we can have some collaboration, and thank you for the opportunity.
Yeah, for sure. And also we have several minutes left, and maybe we can share some problem or ask a question from the audience, maybe. I don't know.
Yes, may I have a question?
Sure, welcome, please.
Thank you. My name is Dachuan Shi. I'm come from Technical University of Berlin in Germany. My research area is also CBM and PM for railway assets. So my question, it's a general question. Maybe all of you can answer this question. My question is about the robustness of prediction or diagnosis model. I'm asking because my experience is sometimes the prediction model, especially the machine learning based one, significantly based on the input data and also the variation of some environmental factors. For instance, when we develop some models for specific application scenarios, and when we want to apply these models into a similar scenarios, but with a different environment, this model may not work. So my question is about these issues. Maybe you can share some experience or solutions with this problem. Thank you.
Could you mind to share your screen so that we can see your face? Because you come from Berlin. Okay?
Yeah.
I don't know if it's okay for you. Depends on you.
I didn't dress up, so I'm just working at home.
Who like to give some comments? Well, great, thank you. Yes.
And no problem.
Yeah, young guy, right? Very good.
May I try to answer the question?
Sure.
Yeah. For the modeling of a process or a machine, we need to build this dynamic model instead of we call a static model. Static model is from historical data, but when you apply this model in the real-time diagnosis or real-time monitoring, you need this model to have the ability to learn the new conditions and self-upgrade, such that the model will follow the conditions, historical lifetime conditions of this machine. Is that answer correct?
Oh, thank you. So you mean you built a model, and at first you may use some historical data from other applications, and but you are still collecting the real-time data and updating or retraining this model.
Yeah, you need to use the real data plus historical data. Yeah.
Okay, thank you. Yes.
Thank you, Shi, for your question. Okay.
Yeah.
Is there any questions from other audience? I think the opportunity is very, very important and not so much. So I think maybe we have only one last one who will raise their hands.
If no other questions, may I ask another question?
Sure, the last one is belongs to you. Okay, please.
Okay, thank you. The question is about the integration of this prediction or diagnosis approach in the current maintenance region. I'm coming from the railway industry. I know the current maintenance program in this area is a kind of combination of corrective maintenance and preventive maintenance. The current solution of predictive maintenance is like the vendors of the servers provider of predictive maintenance have its own IT platform it's like a dashboard to show the results of predictions or diagnosis. But how we can integrate this information, diagnosis results into the maintenance program of the customs. I mean, they have some kind of a different program. The custom sometimes have its own maintenance program to schedule the maintenance activities of their own assets. But now the third companies provide a new platform to deliver some results of diagnosis. That's the human to make maintenance decisions. But is that possible to make some kind of integration of a different platform and let the machine or let the program to automatically reschedule the maintenance, for instance, to make the maintenance decision?
Yeah. Great. Who will try to share your comments?
Dr. Wang, I have some ideas from my side. And for the first question, I might combine your first question and then this one. you know, when you are doing research, it's different from the engineering applications. Research is unconstrained, so you can just work a lot, work on the model training, work to try to the different types models to get the best result. But in a real application, it's quite a different situation. First, I think you have, like we defined the 4T technology, the analysis, that's what you are really good at, and the data technology, that's how you get the data and how to make sure your data quality is good. Because data is very important for intelligent system. And the data is different. Industrial data is quite different from the internet data. And it has the very like specific, and they are broken, and it's hard to acquire a large amount of data like the internet data. And based on this kind of bad data quality, you have to generate very good or accurate results or the action. I mean, that will feedback to the industrial system. That's the difficult part, the most difficult part. And the other one is the model. Model is different from these, like you can see the AI models, the deep learning models. The model used for the industrial applications is quite different. You cannot just use the like train the data with train the data and get whatever model you want. You might get good results offline, but when the model goes online, you have meet different issues. That's why we will have to combine the physical model into the machine learning model. So in my opinion, sometimes you don't have to use very complicated models. It might be a very simple model, can work, and the robust, and it will be very robust in the real world. So back to your last question is the IT integration. First, we cannot guarantee our model always work correct online. So we usually have like 2 steps. First, we start to deploy the system, and it will analyze the data and give the suggestions to the operators. So after several rounds, the operator follows the suggestions from the system. Then the model keep on trying to improve its accuracy. Later on, when the model is robust enough, and it can feedback to the control system, eventually it will get the closed loop control. That's the ultimate goal for the intelligent system. Yeah, I think that's all of my comments. Hope it will help you.
Okay, thank you. Thank you very much.
It's a long comments, but I can see you can analyze such a question through the data specs and the model specs, and also in the future chat. That's a very, very good explanation. Thank you. Yeah, Wenjing. Okay, so ladies and gentlemen, because time is out, we have to say goodbye and end our session. I see this is a very successful session because we have a very good speakers from Bergamo University, with Professor Sergio, and also from 4 startups from China side and also Italy side. And I would like to share my thanks to all of you, and I got studied so much from all of you. Thank you so much. Sergio, please say one word if you like.
Yeah,
thank you.
Just to remind that we will have other seminars later in the next weeks. So you can have a better understanding of the seminars in our website that we are updating, and the website is CI-LAM, .org. I'll just show you it to you.
I can show my last page. Okay.
Okay. So you have read. Okay. So the invitation is to go on with the discussion on other technologies, but I think that also from the maintenance point of view, it's important to understand which are opportunities coming from other kinds of technologies. If I remember well, the next one, Jason, should be on application on artificial intelligence, right? Jason, okay.
Yes.
So
okay.
yeah, so this is the and the next one seminar will be the 7th of July on artificial intelligence in Industry 4.0. If I can can I use my screen?
Sure. Please.
Okay. So here in the website, you can find that the next one will be artificial intelligence in Industry 4.0. So I think that this is in line also what we discussed today, because Wenxing, for example, and Air Measure have been on application of artificial intelligence. So I mean, I find there will be further, let me say, flash content for discussion also from the maintenance point of view. On the next one, it will be the 7th of July, and then the 17th we have collaborative autonomous robotics for the factory of the future. Then the 24th of July, an overview of industrial cybersecurity. The 28th, novel power semiconductor devices measure equipment for distribution control grid. And finally, there will be another interesting speech from Professor Tullino, University of Naples, on the 5G society. So I think we have very good opportunities for further discussion in the next webinars. So thank you to all of you for your presence and for the patience also to listen to me. And please, Wenxing, Jeff, Emanuele, and the other colleague from Naples, the other startup from Naples, please go on with the follow-up of what we discussed today, okay?
Yes, thank you.
Okay, sure.
Yeah.
Okay, so thank you very much. Have a nice evening in China.
Okay, good day. Yeah, all the Italy friends and the colleagues. Okay, thank you. Yeah, thank you all for you. And let's have another opportunity to see together in our next session, maybe. Yes. And Wenjing, I would like to welcome you next time to join us to share your speech about the AI, not only the predictive intelligence, but the industrial AI, right? If you like, I will welcome you once again. Okay.
Thank you.
Yeah. So thank you, professors and colleagues. Yeah, let's say goodbye and have a good day. Bye-bye.
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 Thank you.
Jeff,
Bye-bye.
Goodbye.
Bye-bye.
Bye. Bye-bye.
Yeah, good point. Yeah, good.
哎，您好，我可以问一下吗？我有一个问题
讲吧。
就是你们这个中医的那个是清华和米兰理工一起做的，一起办的，是不是？那个主要投资是中国这边吗？
没有投资的，不是米兰理工，是贝尔加莫大学。
啊，Bergamo。
对，和清华大学。没有米兰理工，好吗？
哦，好的，我是米兰理工的。谢谢你们的讲座啊。没有别的问题。
你可以在微信群里跟我们继续讨论，好吗？谢谢你。
哎，好的，谢谢啊，拜拜。
拜拜。拜。